Hello students, and welcome again to my channel. My name is Mr. Meshak Ngige, and welcome to Maths with Ngige. Kindly, if you have not subscribed to the channel, kindly remember to subscribe, share, and also comment how these lessons are being helpful to you. Now, today we're going to be looking at something which we have looked at before, but now we're looking at another way where we are supposed to solve errors when it comes to entering data in numerical analysis. So we have two methods that we have just learned. We have learned about Newton-Gregory forward and backward interpolation formula, and we have also learned and done a few of questions on Newton-Raphson method. So kindly, if you have not met those lessons, kindly you can consider checking out on the lists, on the playlist that I have compiled together for you for numerical analysis. Now, so we have a question here where we are supposed to use finite difference to locate and correct the error that has occurred in the entrance of this data. Now, this the whole question basically is a three-degree polynomial altogether. So it's a cubic equation. Then in the entry of data, then this data was entered, and it was noticed that one of the variables, the data was entered wrongly. So our lesson today, we're going to be checking how do you correct particularly on that, and how do you solve questions that follow from there. Now, so as we know, the solution. So our solution basically will start by, for us to just make the table, so the finite difference table. So I hope this will fit here. Okay, so let's have this. So we have values of x, we have values of fx. Okay, now on this side of the data we shall be having our differences. So we have that. So our value of x go from 9 to 1, 9 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now remember, I always encourage that kindly, if you have some space, you're supposed to have some good space, so that you can leave a space between the variables, okay, the entries, so that you can have at least a space here, because by the end of the day we're going to be finding differences together. So the differences need to be written in between the values. That is in regards to the value of what? The value of fx. Now our value is -2, we have 3, we have 14, we have 40, we have 86, okay, that's 40, 86, then we have 158, we have 262, we have 404, and lastly we have 590. So we're going to find the differences. So we can start by the first difference. Okay, we're going to start with the first difference. So that is 3 minus 2 will give us what? Will give us 5. Then you have 14 minus 3 will give us 11. Then you have 40 minus 14 will give us 20, will give us 26. Then you have 86 minus 40 will give us 40 what? 46. Then you have 86, 158 minus 86, that will be 58, plus 14, that is 72. Then you can have the others. So you have 262 minus 158 will give us 104. So 104. Then you have 404 minus 262. It should give us 142. Then you have 590, subtract 404, we shall have 180, 186. Let me confirm entry here. Yes, it is 72. So that is the first finite difference. Then we go to the second difference. Now remember something. The aspect that you have been told, this one is a cubic. This one is a cubic equation, right? This one is a third polynomial equation. Then we are saying in the fourth value, we are supposed to have zeros, right, together. So the entries, we have a lot of entries, yes, true. But now, by the time we are reaching the fourth difference, our answers are supposed to be all zeros, okay, because our equation ends there, because it is a third polynomial, right, together. So now again we have 11 minus 5, which gives us what? It gives us 6. Then 26 minus 11, that will give us 15. Then we'll have 46 minus 26, that will give us 20. Then you have 72 minus 46 minus 46 will give us 26. Then we have 1 of 4. Then subtract 72. So we shall have that. We shall have 32. We shall have 142 minus 54, that will give us 38. Okay. Then you have 186 minus 186. Then you subtract 140. 142 will give us 44. So now we come to a third difference. So we have to a third difference. So then we have 15 minus 6. 15 minus 6, that will give us 9. Then you have 20 minus 15, that will give us 5. Then you have 26 minus 20, that will give us 6. 32 minus, that will give us 6. 38 minus 32, that will give us 6. Then 44 minus 38 will also give us what? Will give us 6. And I'm sure by now you can already see where we have an error. So then we have the fourth, to power 4. So to power 4, then we know this one should be 0, this should be 0, this one should be 0. Now, we have already checked that now we have an occurrence here, but again we know that the fourth difference should be what? The fourth difference should be 0. Okay, the fourth difference in the polynomial should be 0. Now, so you can see our value that is repeating itself here is 6. So that means this value ought to be what? It ought to be 6. This value also is supposed to be what? To be 6. So these two entries here, alright, these two entries is the one which has a difference. So that means the entry from the first difference going forward, we had definitely somewhere a wrong entry altogether. Now we start correcting. So we make all these values to be 6, so that this value here should be 0 and the value here should be 0. Now so we know now we are correcting the table altogether. So you can see the entry. Now let's start correcting the table. So we replace now here with 6. So we'll have a value here. So we can have a value here. So the first one here should be 6. Okay, 6. Pen is using to write. We have now, so we have 6. We have 6. So now we check the differences. In the differences here, we are okay. Now let's correct this. So we have 20 and we have 15. So what value should I? Remember, we have 26. I have 20, so that the entry is correct here. So the 20 is correct. Now I'm looking for a value which, when I subtract, I'll get this value. So which value will I have here so that I can correct the value? So for me to get 6, I need to have what? I need to have 14. So my value there, entry, should be 14. Then what value should I have here so that I can have 6? So what value should I have there so that I can have 6? That should be 8. Right together? Yes. So 14 minus 8 will give me 6. Now the same way, come to these entries. So we have 46 minus 26. Again, it just gives me what? It gives me 20. Now I want a value here that will give me this value. So remember, all through we're just correcting the values here. We are correcting the values here. Let me write this with a different pen so that you really get to understand what we have changed by the end of the day. So we have our value. So which value should I subtract here so that I may get what? So that I may get 14. So basically you can just take 26 minus 14 and it will give you the value here. So my value should be 12. Then what value should I have here so that when I subtract I get an 8? So I'll change the 5. So for me to get the value, you can just again take 12 minus 8, which will give me what? Which will give me 4. And that one leads us now to the last entries here. So we know 40 minus 14 gives me 26. Then we have 14. Subtract a value here, I should have 12. Okay, so which value should I have? The same as saying 14 minus 12, which should be what? The value should be 2. Okay, let's see if the last entry is okay. 4 minus 2 minus 2. So 2 subtract, then you subtract 2, definitely it gives you what? It gives you 4. So now we can see that the value which was entered wrongly was our number what? Our value 2. Okay, so therefore we can see our value here is 0, our value there is 0. So for the first part of the function, we are supposed to correct the table. So one, we have corrected the table and we have located where we have the what? Where we have the issue. Now let's come to the second part. We're supposed now to determine therefore the general representation of the function fx. Now remember, by the end of the day, at the back of your mind, you should have something here. You should always remember that your function fx is a third degree polynomial. Right, together. So it should be something like x squared, x cubed, 3x squared, and all that. But the highest degree should be what? Should be 3. Now let us now see how do we determine the function f of x. Right. So remember, we shall use the forward difference for us to get the actual value of fx. So now we now determine the value of fx, and by definition, that is using the forward interpolation formula, we know divide this. We know that f of xp given by f of naught plus p, first difference, over 1 factorial, okay, then plus p, then we have p minus 1, second difference, that, then we have 2 factorial. So the sequence continues in that form, and so on. So it will be p minus 2, p minus 1, p minus 2, then you have the factorial, the third difference, then over 3 factorial, and so on. Now our value of p is formed by xp minus x naught over h. All right, where xp is the value that you're finding, x naught is the value above, then you have h, which is the difference in the values of what? Values of x. So you can find that. So our xp, since what are we finding? We are finding fx. So x is what you are finding by the end of the day. It is x minus the value above. So remember here, we're going to use this to use the first difference, the first values. Okay. So yeah, we shall use these diagonal values. The first the differences. Okay, the first differences that we have at the top of the table. So x naught is the value above. So what is the value above? The value above is what? Is 1. Okay. Then over common the difference between the values of x. So 2 minus 1 gives you 1. Okay. So therefore this just becomes x minus 1. So that is your value of p. Now we can get all the other values. So you have p. P is x minus 1. Then you have p minus 1. P minus 1 will be given by x minus 1 minus 1, which will be x minus 2. Then you have p minus remember our values goes up to the third difference, so we'll have to go up to the third. So therefore we shall have p minus 2, which is x minus what? X minus 3. So those are the values of p. So now we shall be replacing the values in this formula that you have here. So remember, what are we finding? We're finding f of x. That is the value that we are determining. Okay. Now, so the f naught here is the first value, is the value of fx, the first value of fx. So it will be negative 2. Okay. Then plus. Then we have our p. Our p is given by x minus 1. Let me bracket this. Yeah, you can have that. So our p is x minus 1. So x minus 1. Then our first difference is given by what? Given by 4. So we have our first difference given by 4. When we come again to p, okay, okay, we have our value of p. Sorry. So we have p. Our p is x minus 1. Our p minus 1 is x minus 2. Okay. Then you have our second difference is given by what? By 8. Okay. Then all over 2 factorial, which is just what? Which is just 2. Then lastly, we have the last value, which will be given by p, which is x minus 1. P minus 1 is x minus 2. P minus 2 is x minus 3. Then we have our third difference, which is given by 6. Then all over 3 factorial. And 3 factorial is what? 3 factorial is 6. Right, together. Now, so we have that. So this will be expansion. So sorry, we have a short board, but basically you can just see the sequence on how that one is arranged. Now we can simplify our functions here. So first of all, we can cancel out the constants. We have a 6 and a 6 there. We have a 2 and we have a, that one we have 4. So therefore we shall have, we can just say equals to, so we shall have negative 2 plus, then we have x minus 1, then we have 4, then plus. We can expand this in this function. So we know x times, can put into bracket first, x times x, x squared, sorry. So x times x is x squared, x times negative 2 is negative 2x, negative 1 times x is negative x, negative 1, negative 2 gives us plus, plus 2, okay. Then we have our 4 outside there, okay, this value here. Then we know that the expansion of this and this gives us the whole of this, so we can just have it with that. So again we have x minus 3, then we have this whole function which is x squared minus 2x minus x. So we can just have this because we have minus 2x minus x gives us 3x, negative of 3x. So we have negative of 3x here, then you have plus, plus 2. Then you have our variable, remember the 6 and the 6 cancelled, so we just have that by the end of the day. So now we can now expand this. So these two terms here can still combine them at this point. So you can just, okay, we'll just write it as we have, as we expand the next. So we shall have negative of 2, okay, then 4 can open this bracket, so we shall have 4x, okay, then minus 4. Now this 4 can open this one up, so 4 times x squared gives us plus 4x squared. Now you can combine this and this to give you negative 3x, then you multiply by 4, which gives you negative of what? 12x altogether, because we have this term and this term are common, so you have negative 3x. Negative 3x times 4 gives you negative 12. Then 4 times 2 gives you, it gives you 8. Then you can expand now this, so we have then plus. So we have an addition sign here, okay. So we have plus. Now expand this, so we shall have x times x squared gives you x, cubed. Then x negative 3x gives you negative 3x what? Squared. X times 2 gives you positive 2x. Now come to the second term. 3 times x squared negative 3x squared. Then you have negative 3 gives you positive what? Positive 9, positive 9x, okay, yes, true. Then you have negative and positive of 2, which gives you negative what? Negative 6. I can just put an addition sign here also. So now you can collect all the terms. You can collect equals to, you can collect all the terms now which are the same. So you can start with the cubic function, the cubic variable, which is x what? X cubed, right? So you have x cubed. Then you go to the square part. So you have the square, we have 4x squared minus 3 minus 3. So 4 minus 3, that is negative 1. That is 1, sorry. Then 1 minus 3 gives you negative 2x what? 2x squared. Then you come to the x variable. So you have 4 minus 12, that gives you minus 8. Minus 8 plus 2 gives you 6. Minus 8 plus 2 gives you negative 6. Negative 6 plus 9 gives you plus 3. Okay, plus 3x. Then lastly, we have now the constant terms, where we have negative 4. We have negative 2, negative 4, that is negative 6. Negative 6 plus 8 gives you 2. Then 2 minus 6, which gives you negative of 2 minus 6 gives you the negative of 4. So therefore your function f of x will be given by x cubed minus 2x squared plus 3x minus 4. So that gives you the function f of x. Now, not something here, but anytime you're supposed to solve a function or to solve for f of x, then you can be given a value for you to find. Either is inside this table or even outside, okay, outside this data that you have been given. For example, we're supposed to find the value of 2.5. So 2.5 is a value that lies between 2 and 3. So we remember we can use forward interpolation formula for us to find it. But now, once you have the fx function, you just replace the value directly. So if I have 2.5, I just come and replace my f of 2.5. Every value of x, I replace it with 2.5 and you'll get a value that lies. And that value definitely, when you use the f of x function, then we shall get a value that is between 2 and what? That is between 2 and 14. You can also use it to find the value of a function that is given outside the distribution that you've been given. So for example, you want to find for a value of let's say f11 or f10. So you can just replace by what? You just replace your value of f10 here, then 10, then you just expand your function and you get the value that you need. So that is all about finding and correcting errors, and also finding the value for the function or the function itself, that is the function f of x. So my name is Mr. Mesha Ngige. Kindly remember to subscribe, share, and also comment how these lessons are being helpful to you. So thank you and see you in the next lesson.